Good morning, everyone. Let's go over this warm up here really quick. And I had mentioned before, if you had joined early, that this drawing or this diagram is kind of like a coffee cup without the handle on it. So that might help you get a frame of reference of what this is telling you when they say the thickness of the concrete is 3 inches. So it's got a wall of 3 inches around, which kind of gives us a little insight. If this is 3 inches and the entire radius of the big outer shape is 18, then I know the inside radius is 15. Likewise, if the big height is 23, and I know this drawing isn't perfect, but this thickness down here is 3 inches. So then the height of the inner cylinder is 20. Because it's 3 inches less than the cylinder there. Now, I'm a fan of setting up what I like to think of as the visual picture or a picture equation. So the total volume of this is really the volume of the big overall cylinder which has a radius of 18, and then the height of the big cylinder is 23. And then what we're doing to that we're actually taking away the volume of that slightly smaller cylinder that isn't as tall either. So its radius is 15 and its height is 20. And since it's volume, we know the volume is area of the base, which is pi r squared, times the height. And it's the same thing for the smaller cylinder. So we know our radius and height for each of the cylinders, which makes this volume fairly quick. And I didn't ask for it, but I'm going to give this answer as an exact answer first, and then I'll show my decimal answer. And the reason why is I think it's kind of important that we talk about how we find the decimal answer really quick. So I'll just show you that. But what do I know? I know the radius and the height. So that's the area of the base times the height. That's the volume. So I'm just going to do 18 squared times 23. And I get 7,452 pi. That's the exact volume of the big cylinder. And then the other one is 15 times 20. Oh, I forgot to square it. That will be 4,500 pi. And then if we subtract those two, I get the total volume of this tank as the exact answer. But there's a strong chance you just plug those into your calculator. So let's look at the rounded answer. And I want to show you something that is kind of important for us to understand. So what if I use the pi button and I just do 2,952 times pi? I end up with and we always round to the third decimal. So 9,273.982 inches cubed. And I'm actually going to make note here. That was with the pi button. What if I use 3.14 instead of the pi button? Right? So what if I take 2,952 times 3.14? Look at the difference here in my answers. Oops. Okay. So I want you to think about which one is the best answer. Well, if you were going to pour the concrete and you had to order the perfect amount of concrete so you didn't have too little or too much, you would want to pick the exact answer, right? However, my guess is if you call the company and order this amount of cubic inches, 2,952 pi cubic inches, they might not fully understand what you're talking about. So what's the next best option? Well, if I use the pi button, that takes more decimals of pi and it gives me a more accurate answer than 3.14. Look at the difference here. We're almost we're over 4 cubic inches difference in volume by just using the pi button versus 3.14. And that's a little hint. The larger the numbers you have, the more of a difference you're going to have in your answer using the pi button versus the answer using 3.14, which is why we don't want you to use 3.14. We always want you to use the pi button if you're going to have a decimal answer, and you should always round that to the nearest thousand, so the third decimal. Okay, so just a little side note, because the larger the numbers are, the bigger error occurs. And if you were in charge of a company, if you order not enough concrete, you are out of luck big time, especially if you know anything about working with concrete, right? They usually actually tell you to order about 10 to 15% more than you need just to be safe. Okay, anyways, couple of things really quick. I want to just mention to you that so today's Friday. Next week we have school Monday, Tuesday, Wednesday, Thursday, which means I will not see you guys next Friday. And I will see you on Tuesday next week. And then you have a test. You have a test a week next Wednesday, February 24th, is our Chapter 12 test. And I'll talk more about that next week on Tuesday. We're going to have a little wrap up. We've got one more section that's super quick to talk about, and then we're going to do a little bit of a review. And then we're going to release the test on Wednesday, so you could take it on that day, or you could take it on Thursday, Friday, Saturday, Sunday. It just has to be in before I see you guys again for March 2nd. But we'll talk about that next week. I just wanted to give you an idea that if you don't count today, we only have 6 days of school left for this trimester, and then it's going by fast. So, all right. The first couple of things we're going to do, I'm actually going to not have you write down. I just want to have you kind of visualize some of the things we're going to be talking about today. So we're doing 12.5, which is all about volume, and we're going to start looking at the volume of pyramids versus the volume of prisms. But let's think of this two-dimensionally before we start thinking of it three-dimensionally. If a rectangle and triangle have the same base and the same height, what do you know about their areas? So you don't have to respond. This is just kind of to get your brain going. So let me show you what we have. If I take this triangle and I match it up, look at the bottoms. The bottoms are the same base, and then look at the height. The height is the same. Well, we actually talked about this when we developed the area formula. So if we think of this from a strictly area concept, the area of this rectangle is base times height, and the area of the triangle was also base times height. However, it filled up half of the amount of space, right? And that's where the formula 1/2 base times height came from. Well, what if we think three-dimensionally now? Okay, so don't write this either. This is just kind of, again, to get your brain going. So what if I give you a prism and a pyramid that have the same base and the same height? What do you know about their volumes? So let's assume that I can draw a nice, perfect cube. All right, so I'm going to call that a cube, and we know that since it's a cube, all of these side lengths would be the same. right? So what do we know about their volume? Well, we've learned the volume of this one already. That's the area of the base times the height. So S times S times S. That would be side length cubed. But what if I turn that same base, so the square bottom, into a pyramid? Now here's where you got to use your imagination. Let's assume that I can create a perfect base as this one. So this length and this length are the same. So there's my side and my side. But now, instead of making it a cube, I'm going to make it into a pyramid. All right. Now, if I drew this perfectly, this height here is going to be the exact same height right here. So there's my side length, right? So that side length is the same as this height. And if I could draw this inside of it, the pyramid would kind of look like this on the inside. It's really hard to do this any justice. But my question to you then is, what do we know about the volume? Well, the volume is definitely the area of the base, which is side times side. And then we usually incorporate the height as well, which is also the same length as S, because that height is the same as the side length. So isn't this volume S times S squared times S, isn't that really the same thing? But we know that it can't be exactly the same because there's a lot of extra space that the cube takes up, which the pyramid does not. So my question to you is, what is the multiplier that makes the volume of a pyramid relate to the cube? And you might know it right now. You might already have that in the back of your brain. But what I want to do is show you a couple videos quick, just to help frame your reference. Okay, now, the volume isn't important on this video, which is fine. I'm going to make it go a little faster. It's not the best quality, I'll give you that. But here's the idea I'd like you guys to think about. Okay, we have a pyramid, right? And it's a square pyramid. You can't really see it right now. And we have a cube, right? So all three sides, length, width, and height are the same. What they're showing us here is that they have the same base area. So that square base is this exact same size. And we flip it upside down, you can see that we have the same height. Okay. Now, my question to you is, if we take this pyramid and we fill it full of water, and then we dump it into so you can see there it's full of water. They put some food coloring in it just so we could see it clearer. I want you to send me a chat right now. How many of those square pyramids do you think it will take to fill up the cube that has the same area of the base and the same height? So send me a quick chat. What do you think? I'll say right now we've had 2 people guess correctly. All right, let's watch. Let's see. So a pyramid that is completely full of water, so that represents the complete volume of one pyramid. And you can see it's not perfectly filled, but we're making an assumption that it is perfectly filled. So there's 2. And quick pour, but 3. It took 3 of those pyramids to fill up that that prism or cube. So what about a cone? Let's just do a quick visual. We're going to make this one go a little faster. So there's my cone, there's my cylinder, same base, same height. How many cones will it take to fill up a cylinder? So that represents the full volume of one cone. And you can probably guess right away, it doesn't matter if it's a pyramid or a cone. If the relationship of the same base and the same height is true, the area of the same base and the same height is true, then that relationship is always a 3-to-1 ratio. So what does that mean for us? We're going to jump back here, and that question of how many pyramids would fit into a cube if you could break it up and split it all together, well, that would be 3 of these would fill one of those. So what's the volume of one pyramid? It is 1/3 the volume of a cube. So when we talk about the 1/3, you have a little bit of a frame of reference of where that 1/3 came from, because this pyramid is 1/3 the size of the cube. Okay, what I would like you to write down is right here. The volume of a pyramid. And we just kind of talked about it. The important part that you understand here is you know where the 1/3 came from, but that capital B, we just have to remember that capital B stands for the area of the base. And that's usually the only spot that kids make an error on with volume is capital B stands for the area of the base. I'm going to draw a picture here. You do not have to draw this unless you want to. Let's say that I have a this isn't a great picture, but let's say I've got a trapezoidal pyramid. Right? When we say the area of the base, we're referring to, well, what shape is the base? In this case, it's the area of that trapezoid. So we'd have to use our area formula for that. We could find that base. And then the height, as we know, this h, is always indicated from the center of the base straight up. Okay. Well, since we know the volume of any pyramid, a volume of a cone is just a different base. So we're actually going to write the area formula or volume formula for a cone by saying, you know what? We already know this is 1/3 the area of the base times the height, but the area of the base of a cone is a circle, and that's pi r squared. So hopefully you don't think of this as like a brand new formula to memorize. If you know the volume formula of a pyramid is 1/3 the area of the base, and you know that your base is a circle, then you just apply that knowledge and there's your formula. All right, quick visual if you want. Remember, the height is always the 90-degree angle perpendicular to the radius. And then that base that we're talking about is the circle. And notice, base doesn't always mean bottom. It just depends on how the shape is drawn. Okay, I would like you guys to try this problem right down here. Knowing that the volume of a cone is 1/3 the area of the base times the height, I'd like you guys to find the radius if the volume of a cone is 48 pi cubic centimeters and has a height of 4. And then I'd like you to send me a chat of your answer here for this problem. Send me a private chat when you're done. Okay, so we have the volume of a cone is 48 pi, and that has to equal to 1/3 the area of the base times the height. Well, we know the height is 4. I don't know the radius, but I know that the formula pi r squared is part of the area of the base. So now the question is how do we approach this? There's more than one way to solve this. This is what I did. I don't love the 1/3 there, so I'm going to get rid of the 1/3 first by timesing by the reciprocal. And when I do that, the 3's go away and the 1's go away on the right side, and I'm left with 3 times 48, which is 144 pi. And then that's left, what that leaves me with is 4 times pi times r squared. All right, and then what I like to do is I like to get rid of the 4 and pi at the same time. So I'm going to divide both sides by 4 and pi. And notice something big here. So 4 and pi reduce out, I'm left with r squared on the right side. But I've got a pi reducing out with a pi. And then I'm left with 144 divided by 4, which is 36. And then we cannot take the square root until the end, right? Until r squared is isolated. So square root of 36 is 6. And then I should make reference, because my volume was centimeters cubed, I should mention that the radius is 6 centimeters. So you want to make sure you include your units on that as well. Now let's say we had a problem like this on a test or a quiz. What you could do is you could take the 6 and the 4 for the height and plug it back in and figure out, is that actually 48 pi? So you could check your answer pretty easily just to confirm that you're doing it right. All right, well, that's our goal today. Our goal is to find the volume of pyramids and the volumes of cones. And sometimes we work backwards, like we did in this example, or sometimes it's just a straightforward find the volume of the right triangular pyramid. So here's another problem I want you guys to work through. And I'll give you a couple of minutes. I would like you on this one to also submit a chat of your answer. So I'll go ahead and find the volume of the right triangular pyramid. All right, let's take a look at this problem here. And I'll give you a little hint. So notice it says find the volume of the right triangular pyramid. Well, right there, when we name a pyramid, we always name it by its base. So that gives you a little hint that we have to find the area of this triangle as my base. If it's helpful to you, when you see this name as the base, some students like to draw it out separately. So you've got in the base alone, you've got a right triangle, and I could call the base and the height 8 and 14. So then if I want to find the area of the base, well, that's 1/2 8 times 14, which is 56. So there's the area of my base. And then all I have to do for volume is do 1/3 the area of the base times the height. So in that case, we basically did all the work already. The base is the area of that triangle is 56. And the height then, the height is indicated from the center of the base to the vertex. So that's 17. And then when I multiply all that together, now keep in mind, you could do 56 times 17 and you'll get 952. And instead of timesing by 1/3, you could also divide by 3. Some students like to do that as well, but however you type it in, we should round accurately to 3 decimals, or you can put the line over the top just saying it's repeating, and that's even more accurate. And then we should indicate units. Even though there aren't any units, you can still write the word units cubed to represent volume. All right? So nothing super crazy there. Okay. I'd like you to try this one. And here's what I want you to do. I want you to draw a picture first. You don't have to write out this explanation, but draw a picture and then find the volume. You do not have to submit this answer. I'm just going to give you a minute or two to work on it, and then we'll go over it. And I think one of the things first is for us to just draw an accurate picture. And that's part of the reason why I didn't provide it, is we want you to think of when they say square pyramid, well, we're talking about a base that's a square, and it does not have to be drawn accurate. Clearly that is not. And then I'm going to draw this one opening downward just for fun. But we know that it's a square, so we know that all of those side lengths are 10 feet. And by the way, if you see the 1 tick mark, that's feet. If there's 2 tick marks, it's inches. So the height then would be indicated by a center point straight down, in this case, to the vertex, and that height would be 50. And then you could put a little 90-degree box saying that we know that that's perfectly perpendicular with the base. All right, well, volume then is 1/3 the area of the base times the height. And the only thing we then have to figure out is the area of this base, which is the square. And we know that the base is 10 times 10, or 10 squared. So there's the area of the base. The height was given to us as 15. And then 1/3 of that. So I would do 10 squared is 100. 100 times 15 is 1500. And if I divide 1500 into 3 equal pieces, my volume is 500 cubic feet for that pyramid. All right, we got one last problem, and this one's we're going to do together just because I don't want you to get too caught up in it. But it's a great problem to review some prior knowledge. So it's up to you if you want to actually write this. We're going to draw a picture based off of this information. So our goal is to find the volume of a cone with a 40 centimeter slant height and a 70-degree angle of elevation. Ooh, we haven't talked about that word in a long time, angle of elevation. So let's draw our picture together, and then we'll just add this information into the picture. Make a cone, and we're going to make it a little bigger than usual, just so we can kind of have enough room to add all the information that we need in there. Okay, so actually, I'm going to use a solid line on this one. All right, for a cone, I know I have to have a height, and I know I have to have the radius. And then we know that the slant height is given by that lowercase l, right? And in this case, they tell us that the slant height is 40. Okay? The part that is new, and we haven't done this in a long time, is this word angle of elevation. And if you think back all the way to first trimester, when we learned chapter 7, right triangle trigonometry, we talked about word problems that said when you're having an angle of elevation, it's kind of like someone is looking up. So picture that person to be right here where the radius and the slant height meet. And then they need to look up at a 70-degree angle. That's how we're going to kind of set that up. Now, for me, I don't love the three-dimensional drawing of this, so I'm going to just redraw it with just the triangle, the right triangle. And then I know that that angle of elevation is 70 degrees. So my goal is to find the volume of the cone, which we know is 1/3 the area of the base times the height. But I don't know the radius and I don't know the height. But I know enough information that I can now find the height and find the radius. I'll give you a second to get caught up. I'm not sure if I went too fast on that. So if we're looking to find the height and the radius, and we know the slant height, and we know this angle that's formed between the radius and the slant height, we get to visit an old friend. Sohcahtoa, right? If I know an angle and I know one side of a right triangle, I can use Sohcahtoa to find any other side that I want. So let's do, we know that the 40 is in the hypotenuse section, so I'm going to use sine or cosine, and then let's say I want to find the height first. So that is the opposite. Remember, opposite of 70 degrees, opposite of my reference angle. So we're going to use the sine function. And it's sine of the reference angle is equal to the ratio of the opposite side, which is, I'll use green for that, we call that h, over the hypotenuse, which is 40. And then all we have to do is, you can, if you want to make this a 1, you can make it a proportion and cross multiply. H times 1 is h, and 40 times sine of 70. Or you could say, well, I have h divided by 40. I'm just going to times both sides by 40. However you want to think of it. We've got 40 times 70 is equal to the height. Change that to green. And then the rest is in our calculator. So I'm going to show you this in case you may have forgot it. So one of the things I have to do, and I think I'm just going to share this with you in case you also notice this, If you're using in form of an online calculator, notice this was the sine of 70 degrees. I need to be in degrees mode. So I'm going to just double check that my calculator is in the correct mode. So when I hit mode, I'm going to go scroll down to radian and degrees, and you can see I was not in the correct mode. So I have to move over to degrees and hit enter. And that's it. Now I'm ready to type in 40 times the sine of 70. So I'll go to second quit, 40 times the sine of 70, and there it is. And then, as always, we want to make sure that we round accurately to the third decimal. So that's looking at this 7, but this 7 would round this up to an 8. So we now have the height. Down here. So now we just have to find the radius, and you have options. If you want, you can use Pythagorean theorem with your answer that you just found for the height, but I really hope that you get more practice with Sohcahtoa. So I hope you notice that the radius is the adjacent side, and I was already given the hypotenuse, so I'm going to use cosine just in case. I want to avoid tangent because I'm not 100% sure. I mean, I am, but if I make an error in the h value to find this side, I don't want to use that to find the adjacent because then I know this is wrong as well, and that just will provide double errors. So anyways, we want to do the cosine of 70 degrees is equal to the adjacent side that we called r over hypotenuse, which was 40. And then this is kind of like that same work that we just did. You got a r divided by 40, so I could times the other side by 40, or I could think of this as a proportion and cross multiply. However you want to do it, the cosine of 70 times 40 is equal to the radius, and then we're just going to grab our calculator again. So the nice thing is I'm already in the right mode. 40 times the cosine of 70. And then just make sure you also round this one appropriately. The third decimal is a 0, but the 8 before or after that would round that up to a 1. All right, well now I have everything I need. I have my height, I have my radius, so we can just plug those into the volume formula. And since our answer already is going to have a good amount of decimals, we're just going to keep all those decimals, and our answer will be a decimal as well. I have my radius squared times my height. And then remember to use the pi button because we want the most accurate answer we can get. And then we also want to round this accurately to the third decimal. And since it's volume, we know that our units are in centimeters, so this will be units cubed. All right, so that was a fun little review of Sohcahtoa. That's kind of why we make problems like this, is so we can also review prior knowledge so those skills remain sharp all the time. Another way they could have done this problem is if they gave me, let's say they gave me the height and the slant height, then you would just do Pythagorean theorem to find the radius instead. So don't forget all that extra right triangle trig stuff that we've talked about. All right, so here's what we got. Please don't leave yet. I want to talk through a couple of things. We are done with notes for today. Reminder, next Wednesday is when the test will be released. So you will be able to take the test on Wednesday if you're ready for it, or you could do it on Thursday next week. Friday, you don't have school next week, so you could do it on Friday as well. You could even do it on Saturday and Sunday, but my goal is to get those tests graded and back to you before March 1st and 2nd, which are the last 2 days of school for this trimester. So I would like you to get that test done sooner than later and not wait until the weekend, just so I can grade it and then have enough time to give you feedback on it. So with that being said, any and all late work is due next Wednesday. So that includes if you have any more opportunities to take the quiz that we took on Wednesday. Remember, you can take each quiz up to 3 times, and we'll take the higher score of those. So if you want, you can go back and fix anything. If you have any missing homework that is currently marked as missing in campus, you can still turn that in. You have to do that by next Wednesday as well. If you didn't do the project yet, you need to get that project from chapter 11 done and in, and just get caught up. If you need any help, I'll be available in my office hours today. And then your homework tonight is to continue the work from Tuesday. So Tuesday you should have started the volumes of geometric solids and delta math. You should have started those 3 problems or problem sets. And then today you're going to finish those 3. And I actually noticed some of you already did that. Once you're done with that, go ahead and submit that to Schoology. And we are done 20 minutes early. So now's your time to go and get some work done or have an early lunch. If you have any questions, please stop into my office hours. Have a good day. We'll see you.